Hello guys, my name is Larry Oguntoye, your chemistry professor. If you have not subscribed to this channel, Read Online Academy, I want to encourage you to subscribe and make sure you click the notification bell so that when I drop a video like this, you'll be the first to be notified. Now, we're going to consider 0620 paper 6-3 May-June 2020. Let us kickstart. A sample of rock salt contains sodium chloride and sand. Sodium chloride is soluble in water. Sand is insoluble in water. A student obtained a dry crystal of pure sodium chloride from a lump of rock salt. These are the steps the student used. So you have step 1, you have step 2, and you have step 3. Now, usually these questions are around, separation techniques, labeling apparatus. So the first question here says, name the apparatus labeled A. Okay, this is a mortar. That's a mortar for grinding, okay, the rock salt. Then the second question says, explain why the mixture is heated and stirred in step 2. Now, when you have the rock salt, after you have grinded it, and you pour it into, the beaker, you have to heat it up and stir. Essentially, it is so that the rock salt can dissolve faster. You need to dissolve it before you filter. Okay, so you need to dissolve the rock salt before it is filtered. And so the dissolution may be slow because the rock salt is in form of block, is in block form. So there is a need to grind, there is a need to let it dissolve faster. So how do you let it dissolve faster? You need to increase the temperature of the solution, and that is why it is heated. And of course, stirring can also increase the rate at which a substance dissolves in a given solvent. Name the apparatus labeled B. The apparatus labeled B here is, a funnel. It's a funnel. State the scientific term for the sand left on the filter paper. When you do your filtration, the substances, any substance that is left in the filter paper is what we call the residue. Okay, any substance that passes through the filter paper is called the filtrate. Okay, so the answer to this question is residue. D. Describe what the student must do after step 3 to obtain dry crystals of sodium chloride. After step 3, to obtain dry crystal of sodium chloride, step 3 is filtration. And usually when you get your filtrate out of the mixture, you need to pour the filtrate into an evaporating dish. So you need to carry out crystallization, because the question is asking what to do to obtain dry crystal. That is the focus there. What to do to obtain dry crystal of pure sodium chloride. Okay, so you need to carry out crystallization and drying, because the question demands dry crystal. So to carry out crystallization, all you need to do is to heat the filtrate in an evaporating dish to crystallization point. Crystallization point is a point where little crystals begin to form as you are heating the substance. Or usually you heat to, until 1/3 of the solution, is left in the evaporating dish. Then you allow to cool. Then you filter off the crystal. Now, at this point, where you have filtered up your crystal will be, will be wet. So you need to dry the filter with filter paper. You need to dry the crystal with filter paper, or you use paper towel. Okay, those are materials you can use to dry. So essentially, to earn your 3 marks here, you need to carry out, heating to crystallization point. You need to cool, filter off your crystal, and dry your crystal using filter paper or paper towel. So when you have done this carefully, you are going to score your. So if you have carefully done this, you are going to score your 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this, and of course you are going to get your 3 points for this. Heating in an evaporating dish, you score a mark there. You heat the crystallization point and you cool. Then of course you dry within, filter paper. You get your 3 marks there. Now question 2. A student investigated the temperature change when aqueous sodium hydroxide neutralizes hydrochloric acid. Then you have the equation of the reaction. 8 experiments were done. Now for experiment 1, polystyrene cup was placed into 250 cm3 beaker for support. Using a measuring cylinder, 5 cm3 of aqueous sodium hydroxide was poured into the polystyrene cup. Then using a measuring cylinder, 45 cm3 of hydrochloric acid was added to the polystyrene cup. The mixture was stirred and the maximum temperature reached was measured using a thermometer. Then the polystyrene cup was rinsed with distilled water. So you look at the second experiment, you were told that 8 experiments were performed. So your focus is to consider what are the variables in this experiment. What are the variables in this particular experiment? So let's check out the variable. We have sodium hydroxide and what? Hydrochloric acid. So 5 cm3 of sodium hydroxide was used in the first experiment. 45 cm3 of sodium of hydrochloric acid was used in the second in the first experiment. So what is the total volume of mixture? We have 5 plus 45, that makes 50 cm3 of mixture. So if you check the second experiment, you have 10 cm3 of sodium hydroxide used, 40 cm3 of hydrochloric acid used, that makes 50 cm3. Here you have 15 cm3, you have 35 cm3 used, making 50 cm3 of mixture. So they vary the volume of sodium hydroxide and of course the volume of what? Hydrochloric acid. As the volume of sodium hydroxide is increasing, the volume of hydrochloric acid is decreasing. Okay, so that's what you have from experiment 1 to experiment 8. And usually the next thing would be you measuring the temperature change. The highest temperature change for each of the experiment was measured. So let us take this A. We are supposed to measure the temperature change from the diagram of the thermometer here. Okay, then the volume of the acid used for the first experiment is 45. Okay, for the second experiment, it's 40. The third is 35. Next one is 30, 20, 15, and 10. So you record the volume of your of your hydrochloric acid used accordingly in this table. Then the next thing is to measure the highest temperature reached by the thermometer. Of course, read your thermometer here. This is 23. Okay, this is 23. This is 25. If you read out this is 27. Okay, then you take your reading. You follow the same procedure. You read this is 29. Then this is 30 reading. Of course, this is 28. And of course, you read 26. Then of course, you read 24. Okay, now you score your full 4 marks here. If you have all the volume of acid completely written, you score your 2 marks. All the volume of the temperature measured, you score your your 2 marks for complete temperature readings from the diagram of the thermometer. You can see, guys, it's pretty simple. Then the next thing is plot the result of the experiment 1 to 8 on the grid. Draw 2 straight lines. You need to be focused on these 2 straight lines through the plot. Extend your straight line so that they cross. Okay, draw 2 straight lines. So you are measuring the highest temperature against the volume of sodium hydroxide. Of course, you know the volume of sodium hydroxide. So you go back to your table. This is your table. Okay, at a volume of 45, at a volume of 5 sodium hydroxide, 5 cm3, we have 23. At 10 cm3, we have 25. So you use that volume and temperature to plot your graph. So at 5 cm3, we have what? We have 23. At 5 cm3, there is 23 here. At 10 cm3, we have this reading 54. Then at 15, take the reading. Okay, go on to at 20, take your reading. Okay, and go on. For 20, we have 30. From 30, plot the value 30 degrees Celsius for the temperature change. Then you move on. At 35, we have 28 degrees Celsius for the temperature change. And you go on for 40, plot your graph. And of course, for 45, you plot 24 degrees Celsius. Okay, then you plot that. After you have plotted that, the next thing is to draw your straight line. draw your straight line. So absolutely important. You use your ruler very straight. Okay, you draw the straight line here. Best fit moves on that way. Then the second one is draw this other straight line. Okay, you go that way. Then you make sure that they cross. Let the line cross at this point. Okay, this point usually marks the highest temperature reached and the maximum volume of sodium hydroxide that neutralize a given volume of what? Of acid. That is the essence of this kind of graph. Okay, so let's answer the question that follows. The point on the graph where the two straight lines cross is where all the aqueous sodium hydroxide react with all the dilute hydrochloric acid to form a neutral solution. So please watch out for these. It says use your graph. That means you're going to use the graph to get these readings that we have here. To deduce the volume of aqueous sodium hydroxide and the volume of dilute hydrochloric acid that react together to produce neutral solution. So show you're working on the grid. So we get to the grid. How do you know the maximum volume of sodium hydroxide? Just go to the peak that you have there. This is the peak that we have here. Trace the peak down to the sodium hydroxide, axis, and you record your value. That is 26 cm3. And if you are asked the highest temperature reached, it is still the same peak. Trace it to the temperature axis, and you get your readings there. So we have 26. Okay, 26 and 24. We have 26. Okay, for sodium hydroxide. And how do we get 24? Because the maximum volume for each of the mixture is 50 cm3 each time. So 50 minus 26 for sodium hydroxide will give you 24 for hydrochloric acid. Remember, the maximum volume for each of the mixture in the experiment is 50 cm3. Mixing sodium hydroxide with hydrochloric acid. So the highest temperature reached from the graph is 31.6. We read the graph here. Okay, 31.6. This is 30. This is 31. And of course, you have three, division here. Each of them will be 2 points. So you have 31.6 degrees Celsius. Okay, so what is the mark distribution here? You are going to be scoring 1 mark for this, 1 mark for this, and of course 1 mark for showing on the grid, for showing on the graph how you got the value. So you get 1 mark for that, making 3 marks for this. Then the highest temperature reached. Okay, you are going to be scoring 1 mark for this value and 1 mark for your unit, degrees Celsius. It's very important to note all these details. Okay, so let's move on. Which solution, aqueous sodium hydroxide or dilute hydrochloric acid, was the most concentrated? So how do you find the one that is most concentrated? You have to go back to your reading in C1, here. So check this value out. 26 cm3 of sodium hydroxide neutralized 24 cm3 of hydrochloric acid. So hydrochloric acid is the more concentrated one here, because we have lesser volume of hydrochloric acid neutralizing a higher volume of sodium hydroxide. That tells us that hydrochloric acid will be more concentrated than sodium hydroxide. This is simply because you use a lesser volume of hydrochloric acid compared to sodium hydroxide. If the value you got was 25 cm3 of sodium hydroxide and 25 cm3 of hydrochloric acid, that will mean that they both have equal concentration. But since your sodium hydroxide was more than hydrochloric acid used, it means that sodium hydroxide is less in concentration compared to hydrochloric acid. I think that principle should be simple enough. So dilute hydrochloric acid is the more concentrated one here, and the explanation is because the volume of hydrochloric acid used is less than the volume of sodium hydroxide used. Okay. So the next question says, on the graph, sketch the lines you would expect to obtain if copper can was used instead of polystyrene cup. And of course, why do we use polystyrene cup? The essence is to retain heat and to prevent heat loss. Okay, at least to a large extent, will prevent the loss of heat. So if you use a copper can is a good conductor. good conductor. So definitely that means a lot of heat energy will be lost if you use a copper can. So if heat energy will be lost using copper can, that tells us that we'll record for each of the experiments, we are going to be recording lesser, temperature, a lower temperature. So to show on the graph the line you will get if a copper can was used, your plot will be lower, okay, will be underneath the first plot that you plotted, because for example at 5 cm cube of sodium hydroxide, instead of getting a higher temperature here, okay, instead of getting a higher temperature here, I'll be getting a lower temperature. For each of your plots, you get a lower temperature. For each of these plots, you get a lower temperature. For each of these, you get a lower temperature because copper can will lose heat energy to the surrounding. But the polystyrene cup retains more heat energy. Okay, so you have the plot for polystyrene cup higher than that of what the copper can. But you still ensure that your line crosses. You can see the extrapolated line. The line crosses one another and you get the same maximum volume of sodium hydroxide used as 26. You still ensure that the maximum temperature you reached will be at what, 26 cm cube of sodium hydroxide. But the maximum temperature reached will be lower than if you use a polystyrene cup. This will be the maximum temperature reached for using copper can. So that's how to interpret the graph in this respect. So E, give one advantage and one disadvantage for using burette instead of a measuring cylinder to add dilute hydrochloric acid directly to the polystyrene cup. Of course, the advantage of using the burette is that the burette is more accurate than using the measuring cylinder. And of course, disadvantage, if you are using a burette, it is slower, and of course that will lead to a lot of heat loss. The burette, when you open the tap of the burette, it runs in form of a jet, unlike a measuring cylinder that you just pour quickly. So the burette is usually very slow. That is just the advantage and the disadvantages of using a burette. And of course, you score your 1 mark for each of these. Okay, now the experiment will be how could the reliability of the results be investigated? How do you investigate reliability of results? So when you do an experiment and you keep getting the same result, it means that your experiment is reliable. You have what we call precision there. So how do you test your precision? You need to repeat the experiment, get your result, and compare the result. That is how to check if your experiment was reliable or not. So you score 1 mark for that. So let's go on to question 3. Question 3 is qualitative, analysis. You have two solid N and solid P, was given for analysis here. So let's check the test and of course the observation. They will be able to make sense of the test and the observation and predict what we're supposed to predict. So usually I tell students to just read the question. What are you testing? What are you predicting? Okay, so let's check this. Solid N was dissolved in distilled water to produce solution, and the solution was divided into 3 equal portions. Now to the first portion, you can see you use your sodium hydroxide, okay, pour it into a solution until excess. That gives an idea that you are testing for what? You are testing for cation. You are testing for cation. You use sodium hydroxide, okay. So when you pour sodium hydroxide into a solution or into a solution, you are watching out for formation of precipitate. So the precipitate, white precipitate was formed here, and the precipitate was what? Soluble in excess, dissolved in excess. So you cast your mind to all the precipitation that could occur, okay, and it could be soluble, white precipitate soluble in what? In excess. Definitely you are predicting your lead, okay, your lead, your zinc, your aluminium. These are substances that could form white precipitate and what? Soluble in, okay, white precipitate and soluble in excess sodium hydroxide. So let's check. Ammonia was also used. The same procedure. You form white precipitate, which also soluble in what? Soluble in excess ammonia. So soluble in excess ammonia, that is what? That is your zinc. Zinc is soluble. Out of these 3, aluminium and lead they will be insoluble in excess what? Excess ammonia. So your zinc is what you are confirming here, that this confirms your zinc. Check your qualitative analysis page and you'll be able to confirm that. Okay. Now test 3, aluminium foil. When you use aluminium foil followed by sodium hydroxide followed by heating, you know that is the test for nitrate. That is the test for nitrate. And they told you here that effervescence was seen. That means a gas was released, and of course the gas turned what? Red litmus paper blue. The only gas that turns red litmus paper blue is ammonia. So this means that ammonia was released from what? From a nitrate. Okay, ammonia was released from a nitrate. So when you combine the two together, this means that you have zinc nitrate present in the solution. So the question says, name the gas given off. Ammonia is given off because it turns blue litmus paper, red litmus paper what? Blue. Okay, and of course we're able to detect the cation there, zinc, and of course the anion to be what? To be nitrates there. So we scored 1 mark for this, and of course you score your 2 marks for predicting correctly the anions and cations that you have there. So you can write your zinc nitrate. If you are writing formula, make sure that you get your formula, correctly. Very important. Or if you are writing that you have ions there, make sure you get the ions correctly. These are the ions that are present, the cations and anions. Okay, cool. Now for the second solid P, describe the appearance of solid P. They already told you that solid P is potassium iodide. Of course, you know that group 1 metal salts are usually, they are white salt. They are white. Okay, so definitely this is going to be a white crystal. Potassium iodide will be a white crystal. Then of course a flame test was done on P. If you don't do a flame test, what do we use flame test to test? We use flame test to test for cation present. Okay, now the cation present here is your potassium, because this is potassium iodide. The cation present is potassium. So when you burn potassium in the flame, what color do you get? You get a lilac color. Lilac. So that tells us it's potassium. Okay. Now E. Solid P was dissolved in water to form a solution. The solution was divided into 3 portions. Now to the first portion, they add nitric acid followed by silver nitrate. To match, you say nitric acid followed by silver nitrate. What are we trying to test for? We are trying to test for halide. Okay, it's a test for halide. Okay, so of course you know your halide here in potassium iodide is iodide. Okay, the halide is iodide. So you are testing for iodide. So cast your mind back to your qualitative analysis page. Okay, when you have silver nitrate reacted with silver nitrate, okay, reacted with a substance that contains iodide like this, you're going to be having a double displacement reaction. You're going to be forming silver iodide, okay, silver iodide and what? And potassium nitrate. And silver iodide is a yellow precipitate. Okay, so yellow precipitate will be observed, will be formed there. So you score your marks for yellow precipitate. Okay, now the next one is a portion of the same solution was added to barium nitrate. Okay, barium nitrate plus something that contains potassium iodide. Certainly there won't be any visible reaction, because what you are going to be having is barium nitrate, reaction between barium nitrate and potassium iodide. So there won't be any visible reaction in that regard. So a few drops of aqueous bromine was added to the third portion of solution P. So when you add bromine to a solution that contains potassium iodide plus bromine, okay, what do you expect? A displacement reaction is going to take place, because bromine is higher than iodine in the reactivity state. So bromine will displace iodine. So we are going to be having potassium, bromide, okay, plus iodine. Potassium bromide plus what? Plus iodine will be formed here. And of course, when iodine liquid has a brown color, dark brown color, okay, iodine liquid, dark brown color, sometimes orange, okay, and sometimes could be yellowish. Okay, so write any of these as your observation. The solution turns brown, the solution turns orange or yellowish. That will be the observation, because iodine is displaced from the solution. Fantastic, isn't it? So let's move on to the last question here, which is question 3. Okay, So you have Stay Clean and Bright White are two brands of washing powder. Both contain sodium carbonate. Sodium carbonate is soluble in water and react, of course, with dilute sulfuric acid to produce carbon dioxide. Plan an investigation to determine which of the two washing powder, Stay Clean or Bright White, contains the greatest percentage of sodium chloride. All you need to do is you just think, look at the reaction. If I react, the two of them contain sodium carbonate. So sodium carbonate can react with what? With acid to produce, salt water and carbon dioxide. So how do I know which of these substances contain more sodium carbonate? So the one that contains more sodium carbonate, we react more, okay, with my sulfuric acid, and of course we produce more gas, more carbon dioxide. If I use equal volume and equal concentration of sulfuric acid and equal mass of what? Of the washing powder. So the one that contains more sodium carbonate will release more carbon dioxide. So I'm going to be collecting more volumes with that. So if I have that at the back of my mind, I'll be able to plan my experiment. Or I could decide to plan the experiment by measuring the decrease in mass of the washing powder. Okay, the one that reacts more with sulfuric acid will be the one that contains more sodium carbonate. And if it contains more sodium carbonate, it means that when it reacts with sulfuric acid, there's going to be a lot of loss in mass. So the powder that contains more sodium carbonate will lose more mass when it reacts with what? With sulfuric acid. So basically, to do that, to measure this rate of reaction, okay, using loss in mass, I need to get my maybe conical flask, put it on the chemical balance, so I can measure the loss in mass as the reaction is taking place. Or I can decide to let the reaction take place in a flask. I can collect the gas in a gas syringe. Okay, that could be another method. The one that produces more gas, okay, contains more sodium carbonates. Okay, so having brainstormed on what to do, let's start to plan the experiment. Okay, so you can use a chemical balance to measure equal mass of the washing powder into a labeled conical flask. Place the flask on a balance and add excess of dilute sulfuric acid to equal concentration to both flasks. This will keep your experiment fair. You can see as you are explaining, you are mentioning the apparatus that you need to carry out the experiment. Then measure the mass of the flask and the content. So because you need to do to find loss in mass, so measure the initial mass of the mass and the content. Then allow the reaction to take place. When fizzling stops, when effervescence stops, when there is no more bubbles formed, it means that the reaction has been completed. Then you can stop the experiment. Then measure the mass of the flask and the content that is remaining. So all you need to do now is to calculate the drop in mass, the difference between the initial mass and the final mass. That will give you the amount of gases that has escaped from the flask. So the flask with the highest change in mass contains the higher percentage, okay, of sodium carbonate. So the second method, which is measuring the volume of gas, okay, produced for each washing powder, you can decide to measure the gas formed. Okay, so follow the same procedure. Measure equal mass of the powder into the flask. React with what? Acid until fizzling stop. Then collect the gas, okay, produced using a syringe or inverted measuring cylinder. Measure the volume of gas produced. The flask with a higher volume of gas contains the highest volume of sodium carbonate. I am pretty sure that this has been helpful. Remember to subscribe to this channel so that when I drop videos, you'll be the first to be notified. Just go and click the notification bell. Go ahead and click the notification bell. It's not corrosive. Just go ahead and click it. No, it's not corrosive. Go ahead and click it. See you guys.